Whether you're building new cloud-native applications or migrating legacy workloads, Azure SQL offers a powerful platform to streamline your database strategy. In this section, what we're going to do is discuss how Platform as a Service or PaaS solutions can be used here, and you can use it to deploy scalable, secure, and fully managed databases, freeing your team to focus on innovation while Microsoft handles the infrastructure. And we'll also explore how and when it's time to migrate into Azure SQL Managed Instance, which will provide us a seamless path for full SQL Server capability, enabling smooth data synchronization and thoughtful planning. From provisioning to performance, Azure SQL empowers you to modernize with confidence and agility. Now let's talk about deploying some of these PaaS solutions in Azure SQL. The Platform as a Service or PaaS offering for SQL Server can be a great solution for certain workloads. The PaaS offering provides less granular control over the infrastructure and regulates management of the underlying components, memory, CPU, storage, operating system, etc., to your cloud provider, which is Microsoft. In this section, we will focus on ways to provision and deploy both Azure SQL Database and SQL Server Managed Instance, as well as provide clear and definitive guidance on the various options when performing a migration to this platform. Here are our objectives for this section. We will do a deeper dive into the PaaS offerings on Platform as a Service here in Azure SQL, looking at both the Azure SQL Database and the Azure SQL Managed Instances. We will take a look at how you can provision and deploy, along with a discussion on using templates for deployment too. We will also look closer at elastic pools and SQL Server Managed Instances. Let's explore the two main Azure SQL Database Service tier models. We have DTU, which is DTU-based and vCore-based. The DTU, or Database Transaction Unit model, is actually a little bit of an older model, and it simplifies our performance management by bundling together compute and storage and I/O into a single unit. It offers three basic tiers: Basic, Standard, and Premium, and this ranges from lightweight dev test environments to high-performance transactional workloads. DTUs are ideal for users who want predictable performance without managing individual resources. For example, Basic supports up to 2 gigs and 5 DTUs, while Premium offers up to 4 terabytes and 4,000 DTUs for really more demanding applications. The vCore model, now the default, provides more flexibility by letting you choose the number of virtual cores and storage independently. It includes general purpose for most workloads, hyperscale for massive, scalable databases, and business critical for low latency, high resiliency needs. vCore tiers are better suited for organizations needing granular control and scalability. For instance, business critical is ideal for financial systems, while hyperscale supports analytics-heavy workloads with rapid restore and read scale-out. Best practices include aligning tier selection with workload needs, monitoring performance, and planning for future growth, especially since hyperscale is a one-way migration. Now let's talk about how to deploy a single SQL database using the Azure portal. This is one of a few options that you can choose from when you deploy Azure resources. Here you can see Create SQL Database, the blade. When we get into Azure, where the users have the ability to input project details such as subscription and resource group, and then define database settings, including the name, the server, the elastic pool usage. And you can see that the selected service tier was defaulted to general purpose. And the compute tier is provisioned, meaning compute resources are pre-allocated and billed hourly based on the number of configured vCores. This setup is really ideal for predictable workloads requiring consistent performance. As you can see, using the Azure portal for deployment is fairly easy to do. It is very intuitive, it's browser-based, which hopefully helps simplify the resource creation and management without really needing to be able to script. It also offers visual guidance, integrated monitoring, and access to templates for consistent deployments. However, this also allows for limited automation, slower scalability for larger environments, and potential for human error if we're going to manually configure everything. You can create your Azure resource in the portal and then view it and even download the JSON template. So every resource that you deploy in Azure will create this JSON template so you can reuse it, and then it's an automated script that you can use from there. Using the Azure portal is ideal though for small-scale deployments, proof of concept environments, or maybe just training scenarios. It is less suited for large-scale, repeatable, or automated deployments, where tools like ARM templates, Bicep, or you can even integrate with Terraform and more if you'd like for this to make it more efficient. So this is one way to deploy. But another way to deploy is you could consider using PowerShell or even Azure CLI to deploy Azure SQL databases. And this has some different advantages that they both offer. What we can do with this is we can see that the user needs, which might be scripting language, maybe they can work more with, maybe people know more PowerShell than CLI. So you can choose the language that you want to work with, and whichever one you feel more comfortable with. PowerShell is deeply integrated with Windows, as a matter of fact, and with Azure services, really making it ideal for complex administrative tasks and for automating the enterprise setting. It supports rich object handling and is well suited for scenarios requiring detailed scripting and control. However, it can be verbose, as we'll kind of compare and contrast it a little bit later on here, especially for beginners. And you can use it outside of Windows environments. So what we have here is we have a PowerShell that can be used. It's a very good option. Microsoft has had it since 2003 server, so a lot of people know it, but maybe you feel more at ease using Azure CLI, which is lightweight. You can use it across platform. It's easy to learn. It's a really great choice for very quick deployments. It's also integrated, it also can be integrated with DevOps pipelines. And then developers working across operating systems will find this also helpful that we've added it in the Azure CLI option. So it's simpler syntax that you can kind of match up the two here and see. It allows for faster execution of tasks. Though it may not have all the advanced object manipulation capabilities of PowerShell, you can choose which one you want to use. So you want to use PowerShell if you're managing a large-scale infrastructure or integrating with other Windows-based tools, and then maybe Azure CLI for rapid provisioning, testing, and automation in the cloud here that's working maybe with a containerized environment. So both tools will support repeatable deployments and can be integrated into the CI/CD workflows for consistency and scalability. And here you can kind of see both side by side, so you can kind of compare the approach. And it highlights, as you can see, some of the key commands that we have here for setting up. There's a server firewall rule that you can see that sets up a blank SQL Server database with the AdventureWorks LT sample database. And it has the performance level set up also next to it. The PowerShell script uses the new Azure SQL Server Firewall rule and the new Azure SQL Database command. Both of those commands are helpful here. While the Azure CLI script uses AZ SQL Server Firewall -rule create and the AZ SQL DB create. So they're similar, but they're a little bit different, as you can tell, both kind of accomplishing the same tasks. And this will showcase the syntax differences and deployment flexibility. So it's really just a preference which one you might want to use here. Another way to deploy Azure SQL is by using the Azure Resource Manager, or ARM template. ARM templates are JSON-based files that define and automate the deployment of Azure resources in a very consistent and repeatable manner. Here we see a PowerShell script that sets deployment parameters, creates a resource group, and uses that new Azure Resource Group deployment to deploy the template. Notice too that the link below to link the GitHub hosted Quick Start sample template to deploy to. ARM templates include consistent infrastructure deployment. They also have automation that reduces manual errors. They support version control and reusability across environments, so they're very handy for that. These benefits make ARM templates ideal for enterprise scale deployments and developments. Also, you can use it with DevOps workflows. However, they can also have complex JSON syntax and a steep learning curve for new users. When using your ARM template, it's really best to separate the logic and configuration using parameter files. That will help to make it a little bit more modular, easier to read and use and to maintain. You can also have it validate the template before deployment and then store them in version control systems for collaboration and tracking. ARM templates can be used to deploy multi-tier applications. You can use them to automate infrastructure in our CI/CD pipelines. You can also use them very easily to quickly spin up consistent environments here for dev and test. And then you want to be sure that you check out the Quick Start templates that are also available in QuickHub, so you don't need to recreate the wheel. We have a lot of these templates up at GitHub that you might want to use as starting points. Here we see that there is automated backup and retention features available in Azure SQL Database, which are built-in protection capabilities. Backups are performed automatically, including weekly full backups, differential backups every 12 to 24 hours, and you can adjust it. We also have transaction log backups that are performed every 5 to 10 minutes, depending on the activity. These backups are stored in geo-redundant storage, ensuring resiliency against regional failures. We also have retention set up for this too, where we have basic and vCore database that will default to a 7-day retention, but it's extensible up to 35, while standard and premium tier databases offer up to 35 days retention also. Long-term retention can even go beyond that if you'd like to do that, can go up to 10 years. And that should support us for compliance and archival needs. Best practices include configuring LTR for regulatory needs, regularly testing restore operations, and managing backups at the virtual server level, not per database. And it can be used to restore deleted databases, recovering from outages via geo-restore, and rolling back to earlier states for troubleshooting or audits. Let's talk about restoring an Azure SQL database. Know that you can restore a database to the same Azure SQL database server, but not over an existing database. Existing database must be dropped or renamed to restore the database to that server. You may also restore a database by creating a new database on a new server in any Azure region. Restore options include point-in-time restore within the retention period using the portal. You can use PowerShell, CLI, or a REST API to do this too. For single databases and elastic pools, this creates a new database on the same server. For managed instances, it can restore to the same or another instance under the same subscription. You can also restore deleted databases to the time of deletion or any point in time within the retention window, but only on the original server or instance. Geo-restore enables recovery in a different region, useful during geographical outages. If long-term retention or LTR is configured, older backups can be restored for compliance or testing. Note that you cannot use the T-SQL restore database command to do a manual restore of your database, although it would be nice if you could. And then restoring an Azure SQL database provides disaster recovery. the ability to roll back for troubleshooting, and a good way to restore deleted or outdated data. Let's focus on the Azure SQL Hyperscale Service Tier. This was designed for extremely large OLTP databases up to 100 terabytes, while offering rapid scalability and high performance. Here we see key features such as instantaneous backups, rapid scaling, and read-intensive workload optimization. Unlike traditional tiers, limited by single-node resources, Hyperscale uses a distributed architecture that separates compute, log, and storage layers, enabling fast scale-out and scale-up operations without limits. To accommodate workload changes and restoring in minutes, Hyperscale also allows provisioning of read-only compute replicas to offload queries from the primary node and to serve as hot standbys for failover. These replicas can be added or removed in real time without any downtime, making Hyperscale ideal for dynamic workloads. Best practices include monitoring performance to adjust compute replicas based on demand, and using scale-out for reporting or analytics, and leveraging fast backups and restore capabilities for operational efficiencies. Hyperscale is great for mission-critical apps with unpredictable growth, real-time analytics, and for large SaaS platforms requiring high availability and performance. Hyperscale is especially beneficial when workloads demand rapid elasticity, minimal downtime, and efficient resource usage as you are billed for the capacity consumed. Now let's take a look at a few Hyperscale use cases. Hyperscale enables organizations to shift from traditional monolithic database systems to a cloud-native distributed architecture. It removes infrastructure limitations by separating compute, log, and storage layers, allowing seamless scaling and built-in high availability. It supports modern development practices. It also offers built-in high availability and eliminates the need for manual infrastructure management. This modernization supports agile development, automated backups, scalability, cost efficiency, and simplified management through the Azure portal. Unlike traditional tiers, limited by single-node resources, Hyperscale supports databases up to 100 terabytes. Its distributed architecture allows seamless scaling of storage and compute while allowing storage to grow independently of compute, so you can scale without performance bottlenecks. This makes it ideal for applications with unpredictable or rapidly growing data volumes, such as IoT platforms or large-scale analytics. Hyperscale is optimized for demanding OLTP workloads that require fast response times and dynamic scaling. It supports rapid scale-out by provisioning read-only compute replicas to offload query traffic from the primary node, and it enables compute scaling in minutes. Additionally, Hyperscale allows instantaneous backups and fast scaling. This makes it perfect for real-time analytics, SaaS platforms, and mission-critical applications that require elastic performance and minimal latency. Hyperscale Service Tier is intended for customers who have large on-prem SQL Server databases and want to modernize their applications by moving to the cloud, or for customers who are already using Azure SQL Database and want to significantly expand the potential for database growth. Hyperscale is also intended for customers who seek both high performance and high scalability. Here are a few performance considerations. Hyperscale uses file snapshot technology stored in an Azure Blob storage, allowing backups to be taken almost instantaneously regardless of the database size. This eliminates backup-related I/O strain on compute resources, ensuring consistent performance even during backup operations. It makes it a good fit for a very large OLTP system or a SaaS platform that needs frequent backups without impacting live performance. It offers fast restores which are completed in minutes, not hours or days, because they're not dependent on the volume of data. This enables rapid recovery from failures or corruption, minimizing downtime and improving performance and reliability. It also makes it a good fit for mission-critical apps where fast recovery is essential, and for business continuity. Hyperscale supports Azure SQL Hyperscale, enhances performance through rapid scaling, efficient data operations. It also does a scale out, which allows provisioning for read-only replicas to offload query traffic and improve availability. And it's ideal for analytics and reporting workloads. It can scale up, which lets you increase compute resources during peak demand, and scale down to save costs. Perfect. It's perfect for e-commerce or financial systems that have fluctuating usage needs. However, Hyperscale has some limitations. It does not support SQL Managed Instance, elastic pools, geo-replication, nor does it support query performance insights. So to summarize, we want to use Hyperscale for real-time analytics, SaaS platforms, and large OLTP workloads. Active geo-replication in Azure SQL Database enhances resilience by asynchronously replicating committed transactions from a primary region to up to 4 readable secondary databases in other regions. This is built on SQL Server's always-on technology. It ensures no partial transactions are replicated, even if the secondary lags slightly behind. Each region includes endpoints for read-write and read-only traffic managed by the Azure Traffic Manager and load balancers. This setup supports high availability, read scalability, and cross-region disaster recovery. This is ideal for global apps. Failover can be planned, ensuring full sync and no data loss, or it can be unplanned, which gives us faster but has the potential for data loss. You can force synchronization for critical changes, though it may impact performance. Monitoring replication lag, also using our sys.dm geo-replication link status, is also recommended. Some best practices include using multiple secondaries for redundancy, scaling read workloads, and planning failovers to minimize disruption. Some of the use cases involved with this range from disaster recovery to global app availability, and even it offers performance optimization through those read replicas. All good to kind of check into. Failover groups in Azure SQL provide automated cross-region, high availability, and disaster recovery by replicating data from a primary SQL database server or a managed instance to a secondary in a paired Azure region. This is built on SQL Server's always-on technology. And what we're going to see is it simplifies DR by grouping databases that fail over together and enabling seamless redirection using a single connection string. So there's no manual updates that need to happen. What you'll also notice is for SQL databases, you can configure multiple failover groups and selectively add databases or elastic pools. For the managed instance, however, all user databases are included in a single group. Failover is an asynchronous option with an initial seeding phase that can take hours depending on the data size. And these failover groups support automatic failover after a grace period or manual failover for planned events. Best practices include ensuring matching resources in the secondary region, planning on that seeding time, which can be a little bit of time to work with, and monitoring replication health. You can also configure read-only listeners to route read traffic to secondaries. You can use these failover groups here for disaster recovery, region relocation, or global app availability, and especially when you want minimal disruption and simplified failover management. Azure Managed Networking is a secure and scalable framework for deploying Azure resources like SQL managed instances within virtual networks or VNets. It ensures that services are isolated from public access and only reachable through approved network paths. The diagram here illustrates how SQL managed instances are deployed and accessed within Azure's virtual network infrastructure. It shows two main VNets, one hosting a SQL managed instance and the other hosting an app. Each VNet contains subnets for apps and services, with the SQL managed instance subnet specifically hosting a managed instance 1 and 2, and SQL managed instances are deployed into a virtual cluster inside of a VNet. And all connections must originate from that VNet or be a peered network. This setup supports direct access from applications within the same VNet and secure connectivity from other VNets or even on-premises environments via maybe VNet peering, VPN gateways, or ExpressRoute. Applications within the same VNet, like an IaaS-hosted app or app service environment, can directly connect to SQL managed instances. For applications in a separate VNet, connectivity is established via VNet peering or a VPN channel, shown in the yellow section labeled Peering VPN. Additionally, on-premises apps can connect through ExpressRoute or VPN gateways, ensuring secure hybrid access. The benefits include enhanced security through network isolation, improved scalability with subnet segmentation, and seamless hybrid connectivity for enterprise workloads. It also supports compliance by controlling data flow and access boundaries. The use cases here include migrating on-prem SQL workloads to Azure. You can use it for a multi-tier application needing secure database access. You can also use it for hybrid cloud deployments. Key considerations include proper subnet planning, ensuring peered networks are correctly configured, and then monitoring traffic for performance and security. Azure SQL Managed Instance Link is a hybrid data replication feature that enables seamless synchronization between on-prem SQL Server databases and the Azure SQL Managed Instance. It uses distributed always-on availability groups behind the scenes to replicate transaction log records from the primary SQL Server to the secondary managed instance, supporting any service tier. This allows organizations to extend their on-prem environments into Azure for high availability, disaster recovery, and read scalability. As you can see from this diagram, it shows us how an on-prem SQL Server with a primary read-write database connects to a read-only replica in Azure via the Managed Instance link. This setup enables hybrid flexibility by replicating data using distributed availability groups. It supports scenarios like using Azure services without full migration, offloading read-only workloads, and even enabling disaster recovery or gradual migration into Azure. Azure services like Synapse, Power BI, machine learning, all of these can access that replicated data from the for analytics and insights. One of the key benefits is its ability to fail over SQL Server databases to Azure in the event of a disaster, ensuring business continuity. And then also, after a failover, you can continue running read-only workloads on the Azure Managed Instance, which will help to minimize downtime. Additionally, the link can be used to offload intensive read-only operations to a secondary database in Azure, improving performance on the primary system. The link feature supports hybrid disaster recovery, making it ideal for organizations with critical workloads that require cross-environment resiliency. It also ensures that transaction logs on the primary cannot be truncated until replication is complete, which helps maintain data integrity. Regular transaction log backups are recommended here to avoid storage issues, and there are many use cases which include hybrid cloud deployments, disaster recovery planning, and performance optimization, and it's especially good for read-heavy workloads. Azure SQL Managed Instance pools allow multiple managed instances to be deployed on a single virtual machine, optimizing resource usage and simplifying management. Each pool is provisioned with a fixed number of vCores, up to 80, which are then partitioned among the individual instances. This diagram shows a VM with a general purpose 16 vCore pool hosting 7 instances of varying sizes from 2 to 4 vCores, all within a VNet subnet. This setup ensures network isolation and security while minimizing IP address consumption, and then each pool uses up to 9 IP addresses. Regardless of the number of instances, some of the benefits include faster deployment and scaling, since operations don't require provisioning new virtual clusters. Pools also simplify IP planning, especially in subnets with limited address space. Each instance has a dedicated CPU and RAM, and the total vCore usage must stay within the pool's allocation. Instance pools can include development and test environments, multi-tenant apps, and scenarios needing quick provisioning of small instances. Pools are supported only on Gen 5 hardware and within the general purpose service tier. They support up to 8 terabytes of storage and 100 databases per pool, with instance level limits applying individually. Instance pools offer a cost-effective and scalable solution for managing multiple SQL managed instances with predictable performance and streamlined operations. Azure SQL Managed Instance backups are automatically managed by the service, offering robust data protection and recovery capabilities. The backup schedule includes weekly full backups, differential backups every 12 to 24 hours, and again, you can adjust that, and transaction log backups every 5 to 10 minutes, which will help us to ensure minimal data loss and efficient storage usage. These backups are stored in geo-redundant storage, providing resiliency against regional failures. Users can also perform manual copy-only backups to our Azure Blob storage, allowing independent backup management without disrupting the automated schedule. Backup retention defaults to 7 days, and it's extendable to up to 35 days. You can manage it through a virtual SQL server level and not at the database level, so we need to note that. And then restore options include point-in-time restore using the portal. You can also restore through PowerShell, CLI, or your favorite API, which will then create a new database in the same or a different managed instance under the same subscription. You can also restore deleted databases within that retention period, but only to the original server or instance. GeoRestore enables recovery in another region during geographical disasters, and long-term retention allows restoring older backups for compliance or legacy application needs. Azure SQL Managed Instance backups have automated protection. They also have fast recovery and very flexible, a lot of flexibility in those restore scenarios. You can then use them in a wide range of scenarios, from disaster recovery and compliance to testing and to be able to roll back operations. It ensures business continuity and simplifies data management in Azure. Now it's time for our knowledge check. Question 1. You need to migrate a set of databases that use distributed transactions from on-prem SQL servers. Which of the following options should you choose? Answer: Azure SQL Managed Instance. Question 2. You are building a new cloud database that you expect to grow to 50 terabytes. Which is the best option for your database? Answer: Azure SQL Database Hyperscale. Question 3. You are building a database for testing purposes that will be used less than 8 hours a day and is expected to be 20 gig in size. Which is the most cost-effective option? Answer: Azure SQL Database Serverless. Now let's see how to provision an Azure SQL database. So welcome to our section on how to provision an Azure SQL database. The lab navigation we're going to do does have some lab files you can use. As you may remember from our first lab, we did one that was available here off of our Microsoft Learning. In particular, we're focusing in on the GitHub lab site here, the github.io for the DB-300 database admin. So you can get your labs right here. You can also set up the environment, and then we're going to go into lab number 2. And you can also go and get a free Azure account. And it's good for 30 days and $200, whichever one comes first. And then you also have an option to go directly to GitHub to get the lab if you'd like to do that lab environment. What this will do is it will give us the ability to download our lab files and the instructions. So however you want to get to these options to use the lab, feel free. And this will give you the ability right here to download both the instructions and the lab files if you'd like. Or you can come here and you can set up the lab environment and then go into lab 2, the instructions, however you want to do it. And I'm going to go now into the Azure environment. And in Azure, I'm in the Azure portal, portal.azure.com. And you can see, I'll zoom in a little bit further into the portal.azure.com. And once inside, the very first thing I'm going to do is I'm going to create a virtual network for my SQL database here. Now, if you don't have a virtual network, remember you can go up to the top and you can type it off the search up there. You can also find it off the favorites there to find the virtual network. However you want to get into it, there are virtual networks that you may currently have. And what I'm going to do is I'm going to create a new virtual network. And I'm going to call this virtual network, let's see, it's a little bit of a different name. So you have to do your subscription. I have to do a resource group too, either choose one or create one. And then right here, I'm going to give it a name. Now, there is some suggestions for the name that come from the lab, so I'm going to choose that. And what I'm going to do is I'll give it the name right here, and then it's going to be in West US 2. So this is where my resource group is at right now, and I can go and do something more to this. I have a lot of options that I can configure here. There's a lot of good stuff you can add to this, like a firewall. The DDoS network protection is also available. Bastion, there's a lot of stuff you can add to this security-wise. I can also see the IP address ranges that it's going to use, and you can see some suggestions or make your own. You can put some tags on it, which are helpful if I want to see who created it, who it belongs to, who should get charged for it. But I'm going to go in and review, and then I'm going to create this, and it's going to go through the validation process. And I'm going to go ahead and just look through, make certain that everything looks good here. And then I'm going to go ahead and hit create. So it'll take it just a moment to deploy our virtual network. And along with its deployment, it will also show you the progress, and it will also give us an option to do a template. So that was very quick. It made it for us. I'm going to go ahead and go to the resource and take a look at it here. And we're going to see that this is a virtual network, and you can get the address space, and you can take a closer look at it. So it looks pretty good here. It looks like it succeeded. Now what I'm going to do is I'm going to go ahead and go back in and create my Azure SQL database. I'm going to look for the tool. Remember, we use Azure SQL to do it. And there's many ways to get to the database, but I kind of like to use the Azure SQL option. It's one stop really to get all of my resources. And if you don't see it here in services listed, you can go up to the top and type in Azure SQL. But I'll move into Azure SQL here. And when I move to this, what I'm going to do is I can see either, I can see the resources that I have. I'm also going to click on Create, and I'm going to go ahead and make an Azure SQL database. And I'm going to scroll down here for a moment so you can see what each database is defined as, what it offers. We have the Elastic Pool database here where you can have multiple databases sharing resources that are on that one server. And then you could also make the database server itself if you'd like, adding resources as you may want to. But this is what I'm going to do. I'm going to go get the A2 here for my server. So I'm going to go into a single database. I'm going to hit Create. And we're going to see other options there, but I'm going to create a single database. It's going to require a subscription, a resource group again, and again, you can use a free Azure account if you'd like to do that. There are some messages up the top about doing that if you'd like. I can also go down to the resource group, and I'm going to use our DP-300 labs, and then that resource group is then created. So what I'm going to do here is I'm going to associate it to a region. And the region is West US 2, so it's a region near me. And then the name of the database is going to be AdventureWorks LT, which is one of the sample databases that we can load right here inside of Azure. But I'm going to need to create a logical server that this database is going to write on. So for me to be able to do that, what I need to do is I'm going to create a new database here. So I'm going to go ahead and I'm going to copy the server name from the instructions for this lab, and notice it's going to tell me, hey, that name's already in use. So I'm going to call it Lab 2, and hopefully that's generic enough here. No one else is using it. And it's going to create it off the database.windows.net, and I'm going to put this in West US 2, which is where my resource is, and then I'm going to go ahead and choose my authentication method that I usually like to use, but I'm going to use both. I usually like to use both here, so where we have the option to do the authentication either through Microsoft Enter ID or SQL or both, but this lab is calling for using SQL authentication, and I have an admin account that I'm going to use here. I'm going to paste it in, and then I'm going to go ahead and put in my password here. Now notice it has to meet some password complexity requirements, and they have to also match, which sometimes is kind of hard to have that happen. And sometimes that's, kind of hard to do, but, a couple times here, and hopefully we're okay. I'm going to click OK. Then I'm going to go do, what I'm going to do now is I'm going to go in here. And so we're not going to do an elastic pool. So I'm going to keep that at no. We're going to keep this in development. I'm going to change out this option here. And right now it's on general purpose, but there's other options that we can choose here simply by clicking the down arrow there. So I'm going to go in and do basic. So each one of these has different resources that it offers. This one, it's a database that has a maximum of 2 gig, and then I can switch it if I want to provisioned or serverless, and I can adjust the min and max cores on it, and even get into where we can auto-pause it if it's serverless. So you can take a look in here and see some of the different options. You can see serverless versus provisioned and what it offers. Notice we don't have a pause with this one, but serverless, if I'm using it, I can choose also to change out the configuration if I'd like to do that. I can go hyperscale, serverless, or provision. Serverless means I can pause it. Notice I can make it redundant. I can do min and max cores also. I can change out the configuration. There's a lot of options here. I can do business critical if I wanted to do that. You can see the prices that they're estimating here right off to the right. I can tell it I want to save some money and bring my own license. Then I can use my on-prem license through the hybrid. Some of these will allow me to do read scale out and then redundant capabilities with zone redundancy here. So it's across data centers in my region, and I can adjust these. I can also choose standard, which is budget friendly here. Not too bad. I can change some things around. I can drag these around. It goes up to 3,000 DTUs, which is the maximum here that it can go to, and it's a mixture of compute and memory. It also gives me a 1 terabyte database size. Here's premium, 4,000 DTUs is the maximum, which is a little bit of an older standard, the DTU. We now use vCores, but we have these resources that can either be vCores or DTUs. And most of the databases will really go up to 4 terabytes. So you have options you can choose, and these are going to be, I'm going to choose basic with that 2 gig for $4.90 in this region. Okay, so I'm going to go ahead and pick that one. And then I'm going to adjust this to make it locally redundant. It's more expensive to do these other options, but it does give you better availability and disaster recovery and high availability. I'm just using this for a test database, so I'm just going to use local. I don't really need the other ones. And then I'm going to go into our networking tab, and I want to set up this database with a private endpoint. So I'm going to choose to add private endpoint here, and I'm going to go find that VNet that I created a little earlier here. So it picked up my subscription, my resource group, my location. I need to give this a name. So I have the name we want to use this for from the lab. It's just we want to make certain it's unique enough name here also. And so we'll call it our DP-300 endpoint. And I'm going to call it to be that, and we'll see if it's going to pick it up, if it's unique enough here. And I'm going to choose my target, which is SQL, and the virtual network should be one we created, which was the one that was our VNet right there. And then the subnet we can use is just the default, and then we're going to keep it with that. It's going to integrate a private DNS here, and I'm going to leave it this way. And I'm going to go ahead and click OK. And then you'll see as we go a little further down, what else is available here that we might need to adjust. And I'm going to go ahead and go out to our security, and you're going to see there's a lot of default security that we can turn on or off. And we'll talk about Ledger and Defender coming up. We'll also talk about the ability to do the different identities coming up. We'll see that you can put our keys into maybe an Azure key vault storage area. So a lot of good options there for security. We can always come back and adjust these settings and then add additional ones if we'd like. So this is a critical one because this is where I'm going to create my database right here. So I'm going to choose sample. That will pull in the AdventureWorks LT database, which is one of our sample databases that you can download, or from here you can use it. We just have to click on it. And then I can put some tags here like before, and we can get back to figure out, who created this. We want to know, who should be charged for this. And then we're going to go ahead and create this. So this will go through the creation process. We want to kind of verify it before we go, make certain that we have the settings correct. And this may take a little bit to run here to create this database. And we can spend some time, seeing how far it goes in here. But it will take some time to cook here. So I can leave this running, and I can go into the template, and I can download the template, and I can deploy the template. I can copy the template. All those good things you can do with this template that we have here. But this will take a little bit of time. So what I'm going to do is I'm going to go ahead and use one of my pre-cooked databases that I've already created. And so I'm going to go take a look at that. And when you get into this, I'm going to go back into Azure SQL, and we'll give this a moment for deployment. and it'll take a little bit, but I'm going to go into Azure SQL here. And in Azure SQL, I already have created a database that I made a little earlier, which is the one right here. So if I go into that, we can figure out how we want to connect to it. And the connection is actually done, or not done through the database, but it's done through the server, the little database server we made earlier. So that database server for this, you can kind of see it here. It's that DP-300 Lab 1. So it's the one here on the right. This is the server for that database. So that would get me directly into the database, and I can click that. And now we can see here a little bit of an overview. You can see the server name right there, which I'm going to copy. And it might be a little bit, I'm going to use it for my connection string in a little bit. But then note too that I can get also and look a little bit more into the data management here. There's settings. I can mirror it to Fabric. There's a query editor that I can use where I can query it. So I just have to be able to authenticate to it. And I can query it with this. I just have to put the password in that matches. And I will have to adjust that password. Let me see if I can do this, if I can get this connected in right now. And okay, so there's another reason it says, not so much the password, I'm being denied the connection now. That's something we need to fix. Okay, I can't get in this way. I could possibly get in over here using the Microsoft Enter ID to connect to it. So I can't do that on the database right here. And I have to do it on the server. So the server is that DP-300 number 1. I'm going to click right here, go into the lab right here. This is my SQL Server right here. That has that database that runs on it, but I could also, if I wanted to, add additional databases to it, which is kind of a nice option. But what I'm going to do is I'm going to go to the database server and into the security and networking here. And I would like to work with this by being able to connect to it. So I'm going to tell it selected networks. I could, I'm going to be able to enable this. I'm going to use this with essentially my client. So this is my client information. I'm going to add it to the list here. So I'm whitelisting it so I can get in. And I could also allow it to work with Azure services if I like to do that. I'm going to go ahead and turn that on also. And then I'm going to go ahead and set this up. So it takes it a moment. I have to add it in, and then now I'm going to get connected to it. So I added my IP for my client, and now I'm going to get connected. And we'll need to have the name of the server to get connected, and I'm going to do that in a moment here. So I had to allow my IP of my client, but now I'm going to come over to Overview. I'm going to pick up the name of my server, and then I'm going to go back to the database here, and that's the server that it's within. And when I come back in here, let me test that query editor one more time, putting in hopefully the correct password. And here we get connected to it. So you can test a few things out. You can run a few queries from here. There's different tables that you can see. You can view stored procedures. It looks like the database is now done here, but it takes a little bit to do it. And right here, you can see this could be helpful using this query editor. You can also go into the Management Studio and get connected to it too. There's a lot of ways to work with it. So what I'm going to do is I'm going to go ahead and pick the name of that server. And we can use that server name earlier here. And what I'm going to do is I'm going to go into the Management Studio, and I'm going to try to connect to it from the Management Studio. So I'm going to go into Connect and Database Engine. I'm going to go ahead and paste in the name of that server that I want to get connected to. And I'm going to have it set up with SQL Server Authentication. There's other options, but we can choose those later. And we're going to go ahead and log into the using the DP-300 admin we made a little earlier. And then I'm going to go put in my password on this. And I'm going to click on Trust Server Certificate. And we might need to do that. And then I'm going to click Connect. And then here we get connected. So we made the database in Azure, and now we want to get connected to it. And you can see it's right here. So there is my AdventureWorks LT, and I connected to our Azure database. So this is very helpful, but I also want to take it a step further, and I want to do a little query against it too. So I'm going to do a new query, and I'm going to go ahead and paste in the query that we have here. So it's giving me the top 10 customer IDs, then customer name. And so it's invalid. And why is it invalid? Well, it's looking for that table, but this is actually under another name, another database. And I forgot to turn that over there. So I could have done, I need to do this under AdventureWorks LT, and then I'm going to execute it again. And there you see it works. And there you have it. You can query for it from the Management Studio. You can query for it inside of the Azure portal. And there we get our results to run. So that looks good. Just a little bit of wait time to make that happen. And maybe it's a little tricky creating some of these networks, but I think the lab instructions are fairly straightforward. Thank you for viewing this session, and I look forward to seeing you in the next.